Good day, everyone. In my case, we're gonna talk all about Milankovitch parameters. So, first and foremost, what is Milankovitch parameters? Okay, so the Milankovitch or astronomical theory of climate change is an explanation for changes in the seasons which result from changes in the Earth's orbit around the Sun. Okay, so the theory is named for Serbian astronomer Milutin Milankovitch. Okay, so Milankovitch parameters, also known as Milankovitch cycles, are a set of orbital and axial parameters that describes variations in the Earth's orbit around the Sun. Okay, so these parameters were developed by the Serbian geophysicist Milutin Milankovitch in the early 20th century to explain long-term climate changes. So sometimes it's just called orbital cycles, and that's because it's all to do with the way the Earth orbits around the Sun. So at different times in our Earth's history, it has orbited the Sun in a slightly different way. So it has moved around the Sun in a slightly different way, and that has affected the temperature on the Earth. So, moreover, it also included the Earth's orbit changes and three cycles and different lines, and the shape of Earth's orbit around the Sun changes from less to more and back to less elliptical in about a thousand and 96,000 of years. Okay, so moving forward, Milankovitch parameters has a three cycles, which is the first is eccentricity, second obliquity, and third is precession. Okay, so let us know first the eccentricity. So, what is eccentricity? Eccentricity is a term used to describe the shape of Earth's orbit around the Sun. So, the variation of Earth's orbit around the Sun ranges from an almost exact circle to a slightly elongated shape. Okay, so Earth's orbit around the Sun, just like the other planet, is not a perfect circle. So it is an ellipse. So it means that the Earth is closer to and farther away from the Sun and at different times of the year. So let's assume that this is the Earth and this is the Sun. So when the Earth is closer to the Sun, this is what we called a perihelion. And it usually happen in January 3. And when the Earth is farther away from the Sun, this is what we called a an aphelion, and it usually happens in July 4. Again, when the Earth, when the Earth is closer to the Sun, this is what we call a perihelion. It usually happen in January. Next, when the Earth is farther away from the Sun, this is what we call an aphelion, and it usually happens in July. Okay, so this is the Sun here. This is the Sun, and uh, this is the Earth. Okay, so sometimes the orbit, the orbit that the Earth takes is very circular, and it passes around the Sun. So, but at other times, it's more, it's more elliptical. So, it's an ellipse shape, which is like an oval. So sometimes it's passing the Sun closer, sometimes it's passing the Sun farther away. So it looks like this. This is the Earth. This is the Earth. Sometimes the path that it's taking. It's more of an excuse me, sorry. It's taking is more of an oval shape around the Sun. So the keyword here, ellipse, refers to the shape of the Earth's orbit. So this happens changes over 100,000 of years cycle. So every 100,000 of years, the climate is warmer, and if the sun and the earth are closer together. Again, so every 100,000 of years, the climate is warmer if the sun and the earth are closer together. Cooler if the sun and the earth are farther apart like here. Because that's all about eccentricity. Okay, so next is obliquity. So obliquity is the variation of the tilt of the Earth's axis away from the orbital plane. The tilt varies between 22.1 degree and 24.5 degrees, and the average is 23.5 degrees. So the obliquity changes in a cycle taking approximately 40,000 of years. So this is to do with the angle of the Earth's tilt surprisingly away from it being perfectly spherical. So at the moment, our tilt is 23.5 degrees. Hence, why the topics are at 23.5 degrees north and south of the equator. Sometimes the Earth is more upright, and the tilt is more like uh like 22.5 degrees, and sometimes it's even more tilted, and it's more like 24.5 degrees. Okay, so it doesn't change that much. It's only 1 degree change in the angle. It's not that extreme, but doesn't mean that we have more extreme seasons. So our winters are very very cold, or our summers are very very warm. So this happens approximately uh, every 40,000 of years. The last one is precession. So what is precession? Precession is the change in the orientation of the Earth's rotational axis. So the precession cycle takes about 19,000 to 23,000 of years. Okay, so around 20,000 years, this still changes. So it actually ends up tilting in the opposite direction like this. So this happens every 20,000 years. And it's to do with the angle of incidence. So those are the three Milankovitch cycles, and these can really be attributed to our long time climate change. So I hope you learned something.